seat. Have a wonderful morning to all of us. How are you today? Are you feeling good? That's great. Okay? Okay. Before we're going to start with our classroom discussion, let us have first our classroom rule. Classroom rule is that you must listen attentively. Again, what is our classroom rule? You must listen attentively. Okay? So the learning competency is that we're going to describe how energy is harnessed from a battery source. S11 12PS 3I-29. The learning objectives are as follows. First, to describe how energy is harnessed in a battery. Second, to illustrate how energy is harnessed in a battery. And third, to write how an energy is harnessed in a battery. Okay? So I have here a different words illustrating in the picture. You must select the different words appropriate to the picture presented. We have hydroelectric, biogas, solar panels, fossil fuels, geothermal. Okay? The first picture. Yes, Mr. Mark? Fabulous. How about the second one? Yes, Miss Leia? Next, Mr. Arvin? Fourth. How about this one, Mr. Jerwin? Excellent. Lastly, we have here Miss Clea. Wonderful. Thank you. So, you may not take your seat. Let's give them a round of applause. Now, I'm going to show you 5 different objects in your next activity. Again, 5 different objects. Your task is that you're going to determine which among the following objects will move with the use of a battery. The first one, the second one, the third one, the fourth, and the last one. Okay? So you're going to determine which among the following objects will move with the use of the battery. Okay, so I need 5 volunteers. First, Miss Leia. Second, Jerwin. Third, Maria Tony. Fourth, Miss Clea. And fifth, Mr. Arvin. Okay? Thank you for your cooperation. Another round of applause, please. Which among the following 5 objects will move with the use of the batteries? So what is a battery? Excellent. Fabulous. Okay. So moving forward, in your next activity, I'm going to group you into 3 groups. All you need to do is that you're going to assemble an open, simple circuit. The materials needed are as follows: the battery, the copper wire, and the light bulb. Using the diagram, you're going to assemble it by group. Each team members or group members will work as a team. So the rubric's criteria will be the basis for grading your points. So the criteria are as follows: originality, creativity, teamwork, and timeliness. For the rating scale, 8 to 10 will be outstanding. 5 to 7, very satisfactory. 1 to 4 is fair. Okay? So your timer starts now. Okay, another 2 minutes. Okay, group number 1. Mr. Leo, can you help with your group? How about you, Miss Leia? How about you, Miss Mayotoni? Okay, go on. Moving forward. Okay, are all groups done with their tasks? Last 1 minute. Again, last 60 seconds. Okay. Thank you for your participation. Let us give one another a round of applause. You may now take your seat. Okay. Did the light bulb turn on after you accomplish the simple open circuit? What causes the light bulb to turn on? Why does the battery makes the light bulb to turn on? See, in our next phase, we're going to explore and unleash all of these things. What is an energy? Energy is the ability to do work. Energy cannot be created or destroyed, but it can change from one form to another. There are two forms of energy sources: renewable or alternative energy sources. The second is the non-renewable alternative sources. The renewable energy source, yes, Miss Leia, can you read? Okay, how about the non-renewable energy? Yes, Mr. Pakibot? Okay, so historical background of the battery. It began with the discovery of Alessandro Volta, an Italian physicist who invented the first battery and presented in the Royal Society in London in 1800. Okay, another proponent. Can you read, Mr. Jerwin? Okay. So the definition of battery is an electrochemical cell that uses chemical reactions to generate electricity. Another definition? Yes? Miss Akat? Okay, how about you? Mr. Ronaldo? Okay. So, moving on, there are three main parts of the battery. The first one is an anode. The second one is the cathode. And the third one is the electrolyte. So, as you can see in the slideshow presentation, there are three main different parts of the battery. The anode is the negative part, negative terminal. The cathode is a positive terminal. And the last one is the electrolyte. There are two main types of battery. Namely, the first one is the primary battery. Primary or disposable battery. You're correct. Example of primary batteries are alkaline, mercury silver, oxide and zinc carbon. How about the other type of battery? We have the secondary or rechargeable battery. Okay, so we have the lead acid and lithium batteries. What are the advantages of using batteries? Everybody, can you read please? Well, how about the disadvantages of the batteries? Yes, Miss Rial. Okay. A battery's voltage output and current rating are determined by the first, the elements used for the electrodes. The second one is the size of the electrodes. The third one is the type of electrolyte used. Okay. So, to have a thorough explanation regarding our content or topic, let's going to watch the video presentation on how an energy harness from a battery.
You probably know the feeling. Your phone utters its final plaintive bleep and cuts out in the middle of your call. In that moment, you may feel more like throwing your battery across the room than singing its praises. But batteries are a triumph of science. They allow smartphones and other technologies to exist without anchoring us to an infernal tangle of power cables. Yet even the best batteries will diminish daily, slowly losing capacity until they finally die. So why does this happen? And how do our batteries even store so much charge in the first place? It all started in the 1780s with two Italian scientists, Luigi Galvani and Alessandro Volta, and a frog. Legend has it that as Galvani was studying a frog's leg, he brushed a metal instrument up against one of its nerves, making the leg muscles jerk. Galvani called this animal electricity, believing that a type of electricity was stored in the very stuff of life. But Volta disagreed, arguing that it was the metal itself that made the leg twitch. The debate was eventually settled with Volta's groundbreaking.
Okay, so as you can see in the video presentation, there are two debating ideas between Luigi Galvani and Alessandro Volta. In the first concept of Luigi Galvani, he believed that there is muscle electricity, or also known as the ideas that each muscle tissue contains an electricity that moves with the twisting motion or jerking motion once it is being touched. But accordingly, on the opposite side, Alessandro Volta believed that some metal parts, when touched with a muscle tissue or any other tissue, it can cause an electrical force or electricity to react.
Experiment. He tested his idea with a stack of alternating layers of zinc and copper separated by paper or cloth soaked in a saltwater solution. What happened in Volta's cell is something chemists now call.
In Alessandro Volta's experiment, he used the zinc and copper as the element for his experiment to test or to prove that the presence of electricity or the presence of battery will be produced out of it. The chemical solution is the sodium chloride, served as an electrolyte in this experiment, and the copper and the zinc as the chemical element used for the experiment.
Oxidation and reduction. The zinc oxidizes, which means it loses electrons, which are in turn gained by the ions in the water in a process called reduction, producing hydrogen gas. Volta would have been shocked to learn that last bit. He thought the reaction was happening in the copper, rather than the solution. Nonetheless, we honor Volta's discovery today by naming our standard unit of electric potential the volt. This oxidation-reduction cycle creates a flow of electrons between two substances, and if you hook a light bulb or vacuum cleaner up between the two, you'll give it power. Since the 1700s, scientists have improved on Volta's design. They've replaced the chemical solution with dry cells filled with chemical paste. But the principle is the same. A metal oxidizes, sending electrons to do some work before they are regained by a substance being reduced.
Always remember the acronym LEO is J. LEO is J stands for LEO, that is lose electrons, oxidation is the chemical reaction. G, that is gain electrons, and that is reduction. Always remember that in oxidation, there is an addition of oxygen atom, while it loses an electrons. While in the reduction, there is a loss of oxygen atom and it gains an electron. So in a dry cell battery, the movement is from the negative end, or also known as the anode, it moves to the positive end, and that is known as the cathode. So the net movement of the electrons freely move from one another is from negative end to the positive end. Okay.
But any battery has a finite supply of metal, and once most of it has oxidized, the battery dies. So rechargeable batteries give us a temporary solution to this problem by making the oxidation-reduction process reversible. Electrons can flow back in the opposite direction with the application of electricity. Plugging in a charger draws the electricity from a wall outlet that drives the reaction to regenerate the metal, making more electrons available for oxidation the next time you need them. But even rechargeable batteries don't last forever. Over time, the repetition of this process causes imperfections and irregularities in the metal's surface that prevent it from oxidizing properly. The electrons are no longer available to flow through a circuit, and the battery dies. Some everyday rechargeable batteries will die after only hundreds of discharge-recharge cycles, while newer advanced batteries can survive and function for thousands. Batteries in the future may be light, thin sheets that operate on the principles of quantum physics and last for hundreds of thousands of charge cycles. But until scientists find a way to take advantage of motion to recharge your cell battery, like cars do, or fit solar panels somewhere on your device, plugging your charger into the wall, rather than expending one battery to charge another, is your best bet to forestall that fatal bleep.
Okay, so that's all for the video presentation. Okay, so the key points for this main topic, harnessing an energy from the battery. Inside the battery itself, a chemical reaction known as oxidation-reduction reaction takes place. Without this chemical reaction, there is the absence of the net movement of electrons or negatively charged particle to move from one place to another, where it involves a transfer of electrons from one substance to another, and it produces the electrons. The speed of electron production by this chemical reaction, the battery's internal resistance, controls how many electrons can flow between the terminals. So without the electrolyte, always remember that without the electrolyte, there is no resistance that takes place. There is a free movement of electrons from one end to another end, or one terminal to another terminal. Okay? So the electrolyte will cause the battery's internal resistance, where it controls how many electrons flow from the negative side, or also known as the anode, to the positive side, or known as the cathode. Electrons flow from the battery into a wire and must travel from the negative to the positive terminal for that chemical reaction to take place. Again, the movement of electrons move from, again, altogether, from negative end, or known as a anode, to the cathode, or the positive terminal. A battery can sit on a shelf life for a year and still have plenty of power unless electrons are flowing from the negative to the positive terminal. The chemical reaction does not take place. Once you connect a wire, the reaction starts. Okay. So which part of the battery involved in harnessing the energy? Yes, Miss Resalda? Why did the battery harness an energy? Yes, Mr. Ohano? Excellent. How about the last question? How does the energy harness an energy? How does an energy harness in a battery? Yes, Miss Rial? That's awesome. Okay. In our values integration, since battery is made up of hazardous elements, what must we do in order to be environmental friendly in disposing our used batteries in our community? Okay, silent please, silent. May I request everybody to raise their right hand if you wish to answer the question. Yes? Miss Monica? Extravagant answer. Okay, thank you. Let's give everybody a round of applause, please. Okay. For your next activity, with the same group that you had in the previous activity, you're going to perform each specific task using the same rubrics criteria for your assessment.
Group number 1, make a 2 minutes audio recording on how an energy harness from a battery. Group number 2, illustrate a diagram on how an energy harness from a battery. Group number 3, write a 1 paragraph on how an energy harness from a battery. Are you excited for the next activity? And that is your quiz time. Kindly prepare yourself and your ballpen with you, and I will give you the test paper. Kindly answer it for 2 minutes only. Moving forward, for your assignment, make a flow chart on how an energy harness from a battery.
questions, clarifications, violent reactions, or additional information perhaps? Again, none. Okay, since there are no other violent reactions or questions perhaps, I congratulate you all for your participation. Once again, thank you and have a nice day. For our references are as follows.